Okay, so welcome guys. So today let's talk about results called prime square mod 24. Okay, so theorem says that if p is prime greater than 3, then we want to prove that p square minus 1 must be divisible by 24. So 24 is divisible, p square minus 1 divisible by 24. Or one can say that p squared minus 1 is 0 mod 24. Okay, so let's see an example. So let's say p is 5, right? So 4 times 6. Okay, so I should write as 20 p squared minus 1, which is 24. P is 7. So 7 squared minus 1 is 48, right? Still mod 24. Is 0. Okay, and how about p is 11? 11 squared minus 1 is 120. Still 24 times 5. Okay, so this video give a show proof, easy proof of why this is true. So proof. Okay, so notice what? Notice that I can write let's say p minus 1, p plus 1, right? So in order to prove that p squared minus 1 is divisible by 24, so is the product of these two, right? The product of these two is basically p squared minus 1. So let's see, let's first claim 3 divides p squared minus 1. The reason is that these are 3 consecutive numbers, right? And the 3 cannot be divisible by p, since p is greater than 3 and the p is prime, right? So 3 must be divisible by one of these. So 3 must be 3 p squared minus 1 must be divisible by 3. Okay, and then claim what? Claim the 8 is divisible, p squared minus 1 is divisible by 8. Okay, the reason is that let's say p minus 1 is just some k, right? 2k, right? P minus 1 must be even, so p plus 1 must be 2k plus 2, right? So p squared minus 1 must be 4k, k plus 1, right? But k times k plus 1 must be even, right? So there will be another 2 here. So 8 8 divides p squared minus 1. So combine these two, while we conclude that 24 is divides p squared minus 1, or p squared minus 1 divisible by 24. Okay, the simple proof. Simple number theory. See you guys in the next videos. Subscribe to my channel.